Hi, my name is Russ Christoff, and you and I are going to spend the next few minutes attending a very different kind of seminar together. The subject is one that's a top priority for most IS managers today, getting the most from a multi-vendor information system. Desktop computers, workstations, mini-computers, and mainframes started out as separate universes, different missions, different strengths, and different benefits. Now, these universes are starting to come together, and in the years ahead, we have the opportunity to create a more unified systems environment. That's going to help our people and our organizations work more effectively. It will make information technology an even more powerful strategic resource. Now, given the budget constraints we all face, the challenge will be to build this new unified system on the foundation of hardware and software already in place. In this seminar, I'll show you some tools from Apple and other developers that can help you to do that. I also want to talk about the philosophy behind these tools, the approach that Apple Computer takes to information systems. And then, following the seminar, we'll take you by means of video to visit some IS managers around the country who are using this approach and these tools with tremendous success. They'll give you first-hand accounts of their experience in moving the desktop computer into the broader information systems environment. Let's start with an overview. An ideal systems environment is one that makes the most of all your resources. Mainframes, mini-computers, PCs, networks, software, databases, and of course, your people. We believe that the value of information lies in the ability of people to work with it, to understand it, and to communicate it. We'd like to bring together all the information that an employee needs, right at the desktop computer. We want to make it simple to collaborate in a work group, to view corporate information on sales and financials, to manage personnel transactions, and to work more closely with both suppliers and customers. Whatever information you need for your work should be as easy to get at as if it came from a local floppy disk. And whatever tools you need to analyze that information should be as responsive as a local spreadsheet or word processor. Seen this way, the desktop computer becomes the center point in connecting people and information.
My view is the user shouldn't care where the data is as long as he gets it and he can do something with it. We've got more data than we know what to do with. Okay? So now you talk about, okay, now how do you bring that to the desktop so that I can do something with it? The whole idea is you get the stuff into people's hands, they'll use it. You know, give them the tools, teach them how to use it, and encourage them. There's tons of bright people out there. But I don't want them to be computer scientists. I want them to be the most innovative, customer-oriented bankers in the universe.
Now, given the fact that Apple Computer is sponsoring this seminar, it probably won't surprise you that I'm going to recommend that Macintosh personal computers are the ideal choice for integrating your systems environment. I guess it would only surprise you if I didn't. But I can back up that recommendation. I'm going to outline 4 specific goals that any desktop computer should meet in order to be fully useful in a multi-vendor environment. These goals are consistency, connectivity, growth, and integration. It's only by excelling in all 4 of these that a personal computer can be thought of as a universal client. What you'll learn in this seminar is that Macintosh, better than any other PC or terminal, meets all 4 goals and fulfills the role of a universal client. When the seminar portion of this tape is over, by all means continue viewing. What you'll see is a more in-depth demonstration of some of the products and capabilities we'll be touching upon during the course of this seminar. And for good measure, we'll show you some case histories from organizations around the country. Ready? Then let's move ahead. The great paradox of computing these days is that as desktop machines all strive to become simpler, the amount of information available over the network is increasing at an astronomical rate. So the desktop computer needs to deal with everything that's out there. Or, more to the point, the user has to deal with it all. If the user gets lost in the network, then the network's not going to be very useful. And that's something that Apple can help with. Consistency is one of the most important design principles at Apple. We believe that from the user's perspective, viewing the network should be as simple and consistent as viewing a local hard disk. And we think that viewing a local hard disk should be as simple as viewing the documents and files on your desk. Let me show you what I mean. We give users the option of looking at directories and subdirectories as a series of folders on the Macintosh desktop. Opening this folder of quarterly reports will give us a look at the documents contained inside. This view not only gives users a more intuitive picture of how information is stored, but it also gives them the freedom to sort and reorganize their files by moving them directly from one subdirectory to another, without having to keep track of complex hierarchical trees. You have complete freedom to move any document or folder from one subdirectory to another. Now let's look at a few networking options. We'll see how Macintosh gives your people a consistent way to work with the resources out on your network. Every Macintosh comes with a utility called the Chooser. The Chooser lets you connect to anything on the network: a file server, printer, electronic mail, a modem, or a host, in exactly the same way. Just point and click. For example, this icon represents Apple's LAN-based file server. It's a product called AppleShare. Here's how we would select and mount an AppleShare file server onto our Macintosh desktop. Point to the server, select a volume, and the new icon appearing on the desktop tells us the server is mounted. We can follow the same pattern to mount a digital VAX computer. Give a password, and the VAX icon appears, telling us that the VAX resources are now available. From the user's perspective, the mini computer is just another peripheral, and the same routine allows us to select and mount a Novell file server. Now we have 4 different environments, all available on the Macintosh desktop. And as long as we're mixing and matching, here's a floppy disk from an IBM PC containing some Lotus files. All models of Macintosh now feature the Apple SuperDrive, which reads from and writes to MS-DOS disks, as well as Macintosh disks. And with a program called DOS Mounter, the icon for the IBM disk shows up on the desktop. So now we're looking at all these environments: our own hard disk, an AppleShare file server, a VAX, Novell, and MS-DOS. Now let's see consistency in action. Working with files from remote systems, you follow the same procedures as working with files on the local hard disk. I can open the local hard disk and look at its directory. In the same manner, I can look into the file server directory, or the VAX, or the Novell, or the IBM floppy. And I can copy a file from any source to any destination simply by dragging its icon. Here I'm selecting a file from the AppleShare server and copying it onto the VAX. I just drag the icon, and that's all the VAX command structure a Macintosh user has to know to copy a file. There's another type of consistency worth mentioning, possibly the most important kind, and that's being consistent with yourself over time. Beginning with the very first Macintosh and continuing for every year since, we've seen to it that our user interface evolves in a logical and consistent manner. So as we introduce new computers or even new versions of our system software, nobody has to start over with Macintosh.
Consistency of the user interface is important. We think it's valuable for the company in terms of their business, but also in terms of the investment that they put out for computing, to be able to evolve a system or to be able to evolve a platform. It's kind of like the duck paddling. It looks pretty calm on top, but underneath a lot's going to be going on, and that's going to be the information services group. Their role is to be the feet paddling underneath the water.
Well, as you might imagine, there's a bottom line advantage to all this consistency. That advantage is time. Time saved in training, time saved in support. In this study conducted in March 1990, MIS managers and users report that, compared to MS-DOS, Macintosh requires less than half the initial training time and nearly half the training time needed for Microsoft Windows. They also said that learning new applications on Macintosh takes 50% less time than on MS-DOS and 40% less time than on Windows. What's more, they report that it takes more than twice the time to learn how to use a network with MS-DOS than with Macintosh. 80% more time with Windows.
If you go back 20 years ago, computer systems were very expensive, and the actual employees or the people were inexpensive. Now, just the inverse of that is true. The people are expensive, the computing systems and technology are inexpensive, and MIS departments have had to change the way that they think and the way information systems needs to be applied and supplied to corporations.
You know how many people in your company use a computer and how expensive their time is. Now that you know how much less time it can take those people to learn and use Macintosh computers, run your own numbers. You've got a nice surprise coming. Considering the way computer companies toss around words like open systems and standards compliant these days, you'd think that the whole issue of multi-vendor connectivity was a problem that disappeared long ago. Well, we both know that the connectivity problem hasn't disappeared. But Apple is making it a whole lot less complex. What if I told you that with Macintosh, your people can have a completely consistent way to access and work with nearly any network and host system out there? You'd probably say, prove it. Okay. What you're about to see is something that no other PC or terminal can do. Simple, consistent access to 4 very different computing environments. IBM 3270, Digital VAX, MS-DOS, and Macintosh. In the previous section, I showed you a consistent way of looking at files and directories on different systems. Now I'll show you a consistent way of working with them. First, we'll ask for a file from the IBM mainframe. In this window, Macintosh is emulating an IBM 3270. We're using MacDFT to talk to the mainframe over a token ring network. If your company's host goes by a different name or number, don't worry. There are Macintosh terminal emulators for virtually any mini-computer, mainframe, or supercomputer. Okay, here's our IBM data. And we'll shrink this window down. Next, I'll bring up a VT100 emulation to look at some data on a digital VAX. Logging on, and password. And here's a table of sales figures that is stored on the VAX. We have the 2 remote sessions going. Now let's open some local applications. Let's say we'll also need some of the data in a Lotus 123 spreadsheet. No problem. Several Macintosh spreadsheets can read files directly from 123. Or, thanks to an MS-DOS emulator called Soft PC, we can actually run Lotus 123 on the Macintosh. So this window lets us view the document on the Macintosh exactly as it would appear on any PC. All right, last but certainly not least, we'll open a couple of popular Macintosh applications, Microsoft Excel and Microsoft Word. And there you have it, flawless, seamless connections with the 3270, VAX, DOS, and Macintosh worlds, all at once and all on one client. But so far, we're just looking. Now, let's get to work. The Macintosh operating system supports several ways of integrating data from multiple sources so users can work with it easily. Throughout this seminar, we'll be showing you a number of ways to do that. But let's start with a simple copy and paste. Let's say someone needs to prepare a report on recent sales activity. Here's our 3270 session. Enlarging the window, I'll show you how we add the benefits of the Macintosh interface. I'll select this data set just by dragging with the mouse. And a standard Macintosh pull-down menu lets me copy it with the command Copy Table. The Macintosh is now holding this data in a section of memory that we call the clipboard. And I'll shrink this window down so I have room to work in the Excel window. Pull down the menu and paste right from the clipboard into the spreadsheet. Shrink the Excel window and look at the VAX. Again, we've added some Macintosh functionality. I can select the range of data we want. Copy Table brings the data into the Macintosh clipboard. Now I'll put the VAX session aside. Bring Excel into the front again. And paste these figures. And we have a total from the new figures. So now our Macintosh spreadsheet has helped us to compare projected budget against actuals. I'd like to chart these figures. Let's ask Excel to make us a new file as a chart. I'm going to want to paste the chart into another document, so I'll click down here and make it a little smaller. There. Now I want to add this chart into a written report, so I use the command Copy Picture. I'll bring up our word processor and paste. Let me summarize what we've just done. On the system side, we've not only made the connection to these various environments, but we've also integrated data from all of them. And on the human side, we've done it in a simple, consistent fashion. Terminal emulation, MS-DOS emulation, and Macintosh, all with a consistent menu interface for transferring data from one source into another. A little later in the seminar, I'll show you Macintosh tools for creating a level of integration that's even simpler for users. But first, let's take a look at the connections themselves. And the place to look is right here. As you probably know, every Macintosh has built-in support for a simple local area network based on AppleTalk. But what you may not know is that the network architecture of AppleTalk also supports high-performance options. So with optional hardware, AppleTalk can run on Ethernet, X25, or Token Ring. You can use special versions of AppleTalk to connect to DECnet and to PC networks such as Novell, 3Com, or Banyan. To round out the connectivity story, Macintosh connects to IBM PC and mainframe environments, digital, TCP/IP, and OSI. What all this means in 60 words or less is that Macintosh is far more universal than you may have thought possible for a client machine today. From this single desktop, you can connect to dozens of different host computers. And on that note, it's time for us to connect with the next session of our seminar. Anyone who's been working in information technology for more than a week knows that the only constant is change. Everything changes, including the name and mission of the function. EDP, MIS, IS, IM, IT, ISNT. How many of those titles have you seen in your career? At Apple, we recognize that change is driven by two forces. One is technology. There's probably no other industry that has seen such radical improvements in price-performance ratios. And as memory, processing, and network bandwidth improve, the technology doesn't just speed up, it expands to encompass new data types and new applications. The other force that drives change in our industry is environment. Global competition, changing skills in the workforce, pressures on time to market, customer focus, and so on. And here's where these two forces come together. Pressures from the environment make it impossible to ignore the opportunities created by the technology. If you're working as an executive in information technology, then you're committed to the same proposition that drives Apple. We both recognize that information technology, properly harnessed, can be a strategic advantage for individuals and organizations. Both as suppliers and as customers, we're driven to the new. We can't rest where we are. But the question is, what do you leave behind when you move forward? What happens when a technology company comes to the limits of a given architecture? Do they hold on to the past and give up the future? Or do they give up on what they have now and start over with a new architecture? From your side of the table, starting over means more support, more training, and all the costs and trouble of rewriting systems. But on the other hand, if you don't embrace the new, you fall behind. How does Apple deal with this dilemma? We found a way around it. You see, way back when the first Macintosh was introduced, and everyone was talking about its icons and mouse and pull-down menus, most people weren't even aware of its most revolutionary idea, a completely modular architecture for hardware and system software. An architecture designed from the start to cope with inevitable change and growth. In the Macintosh operating system, each module handles a separate function like printing, filing, sound, or graphics. That way, as newer, more powerful technologies come along, individual modules can easily be replaced without disturbing the way the system works, and even more important, without disturbing the way people work with the system. Which means it just gets better. It doesn't force you to adapt to radical change. You keep your systems, your users keep their training. Everything you've built and everything you depend on continues to work. The upshot of all this is that Apple has built a growth path into the Macintosh architecture. Innovations can be adopted without disruption. Probably the best illustration of this approach to growth is the way Apple is evolving the Macintosh system software. As users move from System 6 to System 7, they'll find immediate improvements, as well as a foundation for a new generation of application software. System 7 offers refinements to the interface, to online help, and to customization. So, right out of the box, working with Macintosh gets even simpler, yet more flexible for users. Outline fonts will improve the way type looks on screen and in print, even with current applications. In addition to these improvements, System 7 also offers new capabilities that developers can exploit in creating new kinds of applications. Data access language gives local applications direct access to host databases, and in the next session of this seminar, I'll demonstrate how it works. Another key advance in System 7 is Inter-Application Communications, or IAC. And we've seen how Macintosh applications already reach a basic level of integration, being able to copy and paste data from one source into another. With IAC, the data links can be automated, so the changes in one file will be reflected in another. So, for example, you could have a CAD drawing dynamically linked to another program's database. If the user adds a new component to the drawing, the database automatically updates the project's cost sheet. By any measure, System 7 is an important step forward in technology, and yet it runs not only on current models, but on all past models, going back to the Macintosh Plus of 1986. The only modification needed is to move from the original 1 megabyte to 2 megabytes of RAM. For users, the advances of System 7 are a natural extension of a familiar interface. For management, System 7 preserves your investment in software, data, hardware, and training. That will allow you to focus your development resources on exploiting these exciting new technologies to achieve competitive advantage, not on bringing everybody back up to speed. Apple calls that growth without disruption. It's something every user would like to have, and something Macintosh has always provided. Here's another example, AUX, Apple's implementation of the Unix operating system. It complies with all major Unix standards listed here, yet it operates with the simplicity of Macintosh. By combining the power of Macintosh and Unix on a single system, AUX provides users with an extremely flexible computing environment. Users can employ Macintosh techniques for traditional Unix functions, or they can work in the Unix environment. And AUX was designed to run standard Macintosh applications alongside of Unix programs, which means that for the first time, Unix users have access to a broad library of shrink-wrapped productivity applications, and they have access to X-window applications as well. Up to this point, we've looked at the whole idea of Macintosh as a universal client from three perspectives: the consistent way you work with it, the connections it makes to different working environments, and the growth path that allows it to work in new and better ways as the technology advances. But what about the work itself? Like any other computer, a Macintosh must be judged by the things people accomplish with it. So, this would be a good time to shift our discussion from the computer to the application software it runs. We'll start with Macintosh software you can buy right now, right off the shelf, and that's quite a start. Where other platforms are just beginning to assemble a collection of graphically based software, Macintosh developers have been at it since 1984. So by now, there are more than 4,000 titles available. Whatever your organization needs, you're likely to find it already made for Macintosh. And in many areas, word processing, spreadsheets, drafting, publishing, and presentations, for instance, you'll find that innovative applications appeared on Macintosh long before they were introduced on other personal computer platforms, which is not to ignore the popular software available on other computer platforms. As we saw earlier, Macintosh can run MS-DOS programs by means of an emulation program called SoftPC, and I'd like to run one of them now, just to make a point. This document is in WordPerfect for DOS. I'm going to launch the Macintosh version of WordPerfect, and we'll bring the same document into the Macintosh version. I'll move the window so you can see the DOS version as well. The advantages of the Macintosh display are pretty clear. When we open the DOS file under Macintosh, we give users a better way of looking at the information and an interface that makes it easier to work with. The Macintosh can do the same for a host application, giving users a better way to look at the information and an easier way to work with it. Here's an off-the-shelf tool that will let people find the information they need in DB2 without having to learn SQL. It's called GQL for Graphic Query Language, and it's from Andine Computing. Let's start by opening a DB2 session on an IBM 3090. Choose Make Connection, click on Default DAL Connection, and enter your password. GQL automatically responds to the prompts from the 3090 with the information it needs to open a DB2 session. The GQL window displays the graphical data model. Rectangular objects represent tables. Diamond-shaped objects represent relationships between the tables. Let's get some data from the customer table. Click on Name and City, choose Submit Query, and the results are displayed in a row and column format. Let's extend this query to include data from another table. By clicking on the connecting line, we relate the data in the customer table with that in the order table. This invokes the necessary join conditions. Double-click on the order table, click on Date and Amount, and the new result contains data from both the customer and order tables. With a Macintosh and GQL, your users need not be SQL experts to access data from DB2. By shielding users from the complexity of SQL, GQL makes it possible to unlock the value of your DB2 data. It minimizes the need for IS to be involved in routine query generation, and you still maintain your current security procedures. This power is only available with the Macintosh. I'll show you one more program for simplifying mainframe applications, and then we'll move on to the next level of integration. This is McGruff, which uses HyperCard as a front end to the popular Profs program for mail and calendaring. Here is the logon screen. I am already connected to Profs, so let's go directly to the A00 screen. To get my new mail, I simply click on the Open the Mail button. It will now display a list of all my available Profs notes. To read one, I simply click on it, and it opens in a Read Note window. Unlike Profs, where notes are displayed screen by screen, McGruff presents notes in a scrolling field for easier reading. To print this note on a local printer, I choose Print Note on the Macintosh and click OK. To respond to this note, I just click on Reply, and a split window appears for my reply. My reply is now complete and ready to be sent. By simply clicking on Send, it's on its way to Profs for distribution. Let's now review my calendar. With a single click on the main menu button, we can return to the A00 screen, unlike Profs, where you must back out one screen at a time. When I click on the date I want to review, a CurCal command is issued and my appointments for that day are displayed. As we've seen so far, for both standalone applications and those that help to simplify access to your mainframe applications, it's hard to imagine a better computer than Macintosh for running off-the-shelf software. But believe it or not, it's even harder to imagine a better computer for developing your own applications. There are some extraordinary tools for developing Macintosh applications. I'd like to highlight just a few of them. Fourth Dimension from Acius, for example. It's a tool for developing multi-user database applications with graphical interfaces that focus on the user. Richard Wolpert used it to develop software for NBC News, Disney, the LA Rams, and other customers.
Fourth Dimension is a database application for the Macintosh which allows you to create a complete customized interface and also access a local Fourth Dimension database or a remote SQL database on a mainframe. One of the powerful features of Fourth Dimension is that it gives you full control over the Macintosh interface. So you can create a program that looks just like a regular Macintosh application. We can prototype the system so quickly that you can actually figure out what it is you want the system to do without having to spend months and months of time to actually implement a prototype.
The Macintosh development environment is mature and well tested, and the applications it supports range from simple front ends to sophisticated cooperative processing. How can you make a mainframe application accessible to a broader user community and create an entirely new user interface without modifying a single line of mainframe code? The answer is MitemView, together with Apple's HyperCard. What the user sees is a graphical screen with buttons and pop-up menus. This pop-up menu lists various sales channels. I'll want to look at all channels. I also can choose how to view the information. We'll do it by quarter. We'll save this request. Now I return to the work area and begin the connection. MitemView asks me for my password, and from then on the session is automatic. MitemView is logging on for me and running the session. The host sees exactly what it would see if I were using a terminal and responds accordingly. The user, on the other hand, deals strictly with the HyperCard interface, and MitemView makes the translation in both directions. MitemView gives your programmers the tools for building a Macintosh-style interface without affecting either the performance or security of the host code. Finally, I'd like to say a little about Apple Data Access Language, or DAL. And quite simply, it's the fastest way ever to adapt standard desktop software so that it provides transparent access to your host data. DAL is a superset of SQL, and with it, standard off-the-shelf software such as Microsoft Excel has transparent access to host data. It doesn't matter to the end user if the data resides in Oracle, Ingress, Sybase, or DB2. DAL software is installed on both the Macintosh and the host. A query from the Macintosh application is transmitted to the DAL server on the host, which in turn queries the host database management system. The results are passed from the DAL server to the Macintosh and presented to the user's application.
The Macintosh does give us a good platform to hooking up to all of our different computers. The DAL language allows the Mac user to hook into Ingress as we're doing currently. DAL is very powerful. There's no real limit on what you can do in a data acquisition sense. It has all of the functionality of SQL, plus it has the communications functionality that allows the user to sit on a Macintosh and communicate effortlessly with the corporate databases.
The real genius of DAL is that it isolates the development work needed on the Macintosh end from all of the time-consuming code work needed on the host end. It all adds up to a level of integration between desktop and host unmatched in the industry. At the outset of this tape, I suggested 4 goals that define the universal client. First, consistency, both in application software and over the network. For you and your users, that pays off in lower training costs and higher productivity. Second, connectivity, so that the desktop computer can participate as an active member of any information environment. That pays off in the freedom to assemble your optimum system from multiple vendors. Third, a proven growth path that gives you the benefits of emerging technology without the enormous penalties in training, support, and obsolescence. That pays off by focusing development on moving forward rather than catching up. And finally, integration, a working environment that can be built with off-the-shelf applications and proven development tools. That pays off in the ability to make the most of your investment in information technology. In Apple's view, these 4 goals all add up to one larger goal, giving individuals the tools that will allow them to make the strongest possible contribution to the success of your enterprise. Well, we've covered a lot of ground today. You might want to rewind the tape and watch it again. And if we didn't cover enough material to satisfy you, just keep watching. You'll get a closer look at specific Macintosh solutions, and you'll hear from some of your colleagues who have come to know and respect what Macintosh can do for their organizations. So thanks for watching, and remember, keep the tape rolling. There's more coming up in just a few seconds. Now let's look at how the Macintosh can add value to your information systems. In this series of demonstrations, an administrator will pull down data from sales reports so his department can generate a quarterly report and distribute it company-wide. In the first demo, we'll see the Macintosh connect to both IBM and digital host systems, and we'll import data from these remote hosts into a Wings spreadsheet on the Macintosh.
The first sets of data we need are the approved quarterly budget numbers resident on a digital VAX, and the actual numbers contained on an IBM mainframe. We begin by launching our Western Regional spreadsheet, which automatically comes up in Wings. I click the Q1 Budget button, which runs a macro command in Wings. This takes us directly to the first quarter section of the spreadsheet. Next, we go to the Finder and launch Mac Terminal. This allows us to log onto the VAX, where we access our first quarter budget. I enter my username and password. Then I type in Q1 budget to take us to what we're looking for. I then highlight the data. And using Copy Table from the Edit menu, copy it to the Macintosh clipboard. Back in our spreadsheet, I click Paste and Format. This inserts the VAX data into our Western Regional file, at the same time reformatting the data. Notice that by using simple commands, I'm able to import data from host systems into an off-the-shelf spreadsheet. There's no need to hand copy information from my host system in order to use it on my Macintosh. All I do is copy and paste. Clicking Variants runs a macro which takes us back to our starting point. Next, I log onto an IBM mainframe to retrieve our actual first quarter figures. Then I navigate my way through the SNA network to access our host. I type in the file name, highlight the data we need from the mainframe. Again, copy it to the Macintosh clipboard and go back to our spreadsheet. Clicking the Paste and Format button inserts the table from the host into the spreadsheet and reformats it. These new numbers are in blue to distinguish them from the table already there. Not only do I get the percentages I'm looking for, I get them in color to simplify interpretation. Now, let's say we want to graph this data. Just click the Graph button. To complete our session, we save the file and using the chooser, we access the file server in our office. This way, others on our network can get to this data. To access the server, or for that matter any other network device, all we have to do is pull down the Macintosh chooser and select the server. The server will then appear immediately on the desktop. We open an Apple Share file server. Click our spreadsheet and drag it to a Dropbox folder on the screen, where it can be accessed by the Vice President of Sales. Copying files to our server is accomplished in the same intuitive manner we copy any Macintosh file.
We've just seen a Macintosh simultaneously connect to multiple hosts and share that data with Macintosh applications. Merging the host data with our Macintosh was simply a matter of cutting and pasting. Terminal emulation is the simplest way to make the host connection. There was virtually no custom development needed outside of the spreadsheet macros. With data access language, the process of making database queries is greatly simplified. Data access language is now built into many Macintosh applications, and it can access many different relational databases, including IBM's DB2, Digital's RDB, Ingress, Sybase, and Oracle. In this case, we'll be accessing an Oracle database running on a VAX.
I begin by using the chooser to call up the Apple Share file server with the Dropbox and log on as the owner to get at files left by other users. I open it to see that it contains 3 files, one each from the western and eastern regions, and the graph of the sales information. I select the files and simply drag them to my disk to copy them from the network. Then I open the quarter consolidation spreadsheet, a Wings template similar to the Western and Eastern spreadsheets. By clicking the Consolidate button, both files are automatically consolidated. Next, I click the Region detail to determine which region had the greatest increase in profits over projections. The Western region was obviously the big winner at 221%. Leaving Wings open, I now use Fourth Dimension and DAL to connect to the VAX and get the personnel information I'm looking for. To start Oracle on the VAX, we select Open Host under the File menu. Double-click Oracle and type in our username and password. Clicking Oracle again opens the database. I only need to make simple point-and-click actions to get to my data. There's no need for me to have to learn complex SQL commands. Data Access Language does it for me. Back at the menu, I select Modify Staff for an employee list resident on the Macintosh. I click Bill Hamford, our Western Regional Sales Manager, to bring up his employee record. The information on the screen is a composite of VAX and Macintosh data. With Data Access Language, information from host databases is easily incorporated into my application. I select the data I want along with Bill's picture and copy it to the clipboard. I then paste the picture into the corporate consolidated spreadsheet I left open on Wings. To send the report to my area assistant, I now select Quick Mail from the Apple menu. I click the New button to indicate I want to send a memo, and fill in the addressee information. I then type in the subject and write the memo. Next, I click on the Record icon in the voice dialog box and attach a voice message using the built-in microphone. Terry, please prepare the quarterly report using the attached spreadsheets. Include Bill Hemford's biography from DOS WordPerfect. Congratulate him on his fine performance this quarter, then send it to the rest of the executive staff. Finally, to send the memo, I click on the enclosure icon and enclose our graph and consolidated report. And then click Send.
You've just seen how the Macintosh can use a database resident on its own hard drive, fourth dimension, as well as a database on a remote mini-computer. In this demo, the client-side software was built into fourth dimension. The host portion of Data Access Language resides on the VAX mini-computer. DAL acts as an agent on behalf of the Macintosh application to get information from Oracle. Although this demo used a VAX, DAL can run on a variety of host systems. Now, we'll show the power of Macintosh for office productivity. We'll see how Macintosh can work with MS-DOS files along with Macintosh applications and graphics. We'll use Wings, a word processing application, and SoftPC. SoftPC is MS-DOS emulation software that lets us run WordPerfect right on our Macintosh. Then we'll use QuickMail to distribute our report company-wide.
As Terry Sullivan, the VP's administrative assistant, I select QuickMail to check my mail. I click Message and read my memo. Next, I click Play and listen to my voice message. Terry, please prepare the quarterly report using the attached spreadsheets. Include Bill Hemford's biography from DOS WordPerfect. Congratulate him on his fine performance this quarter, then send it to the rest of the executive staff. To retrieve the files from the file server to carry out my assignment, I click Enclosure and select and retrieve our consolidation report and our graph of the sales data. Then, using MultiFinder, I open my company quarterly report. I then go back to my desktop, where I launch the corporate consolidation file, automatically bringing up Wings. Then I copy Bill Hamford's picture onto the clipboard. Quit Wings and paste Bill's picture into our WordPerfect document. But to retrieve Bill Hamford's biographical data, I need to access a file created on MS-DOS. I use Soft PC, which lets my Macintosh emulate an MS-DOS system. Virtually any document or application in MS-DOS can run on my Macintosh using Soft PC. So I launched the PC version of WordPerfect. Notice that I'm using DOS commands to get to my document, even though it's stored on the Macintosh. Then I bring up the document that contains Bill Hamford's bio. I copy it to the clipboard and paste it into my quarterly company report file in WordPerfect for the Macintosh. And save the entire document, which now contains data from an IBM mainframe, 2 VAX hosts, a DOS file, and a Macintosh file server. To distribute the report to the executive staff, I go back to QuickMail and prepare a memo. I fill in the subject and type a message. Then I click on Enclosure to enclose the consolidated report and the graph. I also leave my own personal voice message. Bravo, Bill Hamford, for a job well done. A final click on Send speeds the report on its way.
We've just seen the Macintosh being used for office productivity. We connected to our corporate electronic mail system and created a document that included information from MS-DOS, an IBM host, a digital VAX, and a variety of Macintosh applications. And we were able to do this with very little effort. Now let's hear how one organization, Seafirst Bank, uses Macintosh to gain a competitive edge.
Seafirst Bank is the biggest bank in Washington State. Over $12 billion in assets, over 200 branches, 300 cash machines, 6,500 employees. We're here 24 hours, 7 days a week, 365 days a year. We move $3-4 billion a day in and out of this place in just wire transfers alone. This is an information business. We've got more data than we know what to do with. Okay? So now you talk about, okay, now how do you bring that to the desktop so that I can do something with it? In '85, we were basically going through a massive migration of our technology. We were looking for a device that we could connect to our statewide network to provide local functions in addition to serving as a terminal for the main computer functions like electronic mail and mass information retrieval. Our original thought, quite frankly, was just we'll go slap a dumb IBM 3270 terminal in there. The problem with that is that it doesn't give you the, you could get the electronic mail because that's on the host, but it doesn't give you the word processing or the analytics or any of the graphic stuff or the presentation, et cetera, et cetera. So we're looking around for the alternative, and that's when we obviously had discovered the Mac.
The Macintosh helps us in a big way. The Macintosh is, as I'm sure you've seen, the The Mac is in every one of our branches. We have a ratio of 1 Mac for every 2 people. Our financial analysts can't live without their Macs. Our managers can't live without their Mac. And it's quite a valuable contributor to our bottom line profitability and to our ability to compete.
I think that the Macintosh has given C-First an edge in the banking industry because it provides us the ability to give excellent customer service. Our customer information system is a huge database which allows us to access all the account information on all of our customers at any branch, regardless of when it was opened or where it was opened or where the transaction took place. Anyone that has access to that system in C-First can access that and update it immediately.
The whole idea is you get the stuff into people's hands, they'll use it. You know, give them the tools, teach them how to use it, and encourage them. There's tons of bright people out there. But I don't want them to be computer scientists. I want them to be the most innovative, customer-oriented bankers in the universe.
We had a bank merger. We went through a bank merger, and the bank had a feature of their certificate of deposit product where they were able to generate interest checks to their customers a couple of days ahead of when the interest was actually due. C-First was working on providing this kind of feature to our own customers because we also saw it as an advantage, but weren't going to be able to do that on our mainframe for at least a couple of months. There were approximately between 3,000 and 5,000 checks that needed to be generated. And we chose, rather than the 30 people typing checks for a 2-week period, to use the Macintosh. We actually had an SC30 with an avatar board to sign on to the mainframe and pull down a report, and we actually did this in a background mode while we were at home. The computer signed on to the mainframe itself, looked for the file, pulled it down. All the reports were at our fingertips off a laser printer when we walked in the door. We then manipulated in a HyperCard scenario, changed the data, then passed it with Tempo 2 software over to FileMaker to generate the checks, and it took us a half hour a day to do what we were going to be doing with 30 people at typewriters. It was a real good feeling. I mean, the eyes were wide open, looking at, wow. I mean, it was really exciting.
That can-do attitude, and the use of, in this case, the Macintosh, to pull it off fast. Go from ground zero to up and running, and let's rock and roll, in 2 days or whatever it took her, is where you get your competitive edge.
Today, what I'm doing with the Mac is we're beta testing a DAL product. We're looking at ways to use the Macintosh to more seamlessly integrate the workstation productivity tools with data that lives in databases on our IBM host mainframe. We have a number of DB2 databases that are implemented on our MVS mainframe, and we're trying to figure out appropriate ways to move the data down to the workstations and to use the workstation as a decision support tool. I have my Mac sitting on my desk, and I can use it to talk to a tandem computer. I can use it to talk to an IBM mainframe. I can call up CompuServe through my modem. I can talk to other Macintoshes through AppleTalk, and I can talk to IBM PCs. I can get anywhere using my Mac. So as we learn more and more about how to make the best of each tool on each platform, we'll be able to use the Mac as an integrator and as a product that allows us to pull together the best in each of those applications, wherever it happens to live, and to present it using the Mac.
My view is the user shouldn't care where the data is as long as he gets it and he can do something with it. And if he's doing some kind of report or something or document with the very easy to use, super duper man-machine interface type stuff, and if some of the data's on his Mac and some of it's on the server and some of it's on the host and he doesn't care and it's moving around in real time, you're there. You got it. That's the future.